Okay, all right, guys. So what we're going to do is we're going to go back and review on our conversions related to the mole. All right, and there are really guys. I want you guys writing this because it actually helps get it in your brain. It's a psychological thing, but there are studies that show that. All right, so I want you writing it down, and I want you to write down the examples. Okay, that's with pencil and paper or pen and paper. I don't care which. All right. With the conversions we're doing related to the mole, remember the mole's that great big number. It's what we use so much in chemistry. All right, it's not even funny. It becomes something that it becomes second nature if you go ahead and end up having to take a lot of chemistry throughout college. All right, but there are three main conversions we're going to deal with for this unit, and that will be involved in the quiz. Two of them are always the same numbers. So you just have to, doesn't matter what compound we're talking about. The first one is the mole itself, the number of particles. So 1 mole is equal to how many particles? Do you guys remember?
6.02 times 10 to the 23rd.
Very good. 6.02 times 10 to the 23rd particles. Okay? And that can be molecules or formula units. At times it can be atoms. It can be donuts, but that many donuts would crush us. All right? Okay? So write this down. We're going to refer back to these three conversions. If you're not writing stuff down, don't ask for help later. All right? The next conversion is the one to do with gases. And it's always the same at STP, and we're only going to deal with standard temperature and pressure. What is the volume that 1 mole of a gas occupies? Who remembers? What's the volume?
22.4 liters.
Very good. 22.4 liters. Okay? It does not matter what gas it is. It's a weird thing that we've discovered about nature. No matter what gas it is, it could be a big molecule, small molecule, they occupy the same volume as gases. If you have this many molecules of the gases, they occupy this volume at STP. All right? We're not going to get into calculating non-standard things until the college class. We're just not going to have time. I wanted to get to it before the end of the year, but we're not going to. That's okay. Save something fun for the college class, right? Okay, now, the only one that changes due to the compound we're dealing with is when we were going from moles to grams. All right? And with grams, it'll be the gram formula mass. That's one way we call it. Or the molar mass. And that is what we add up from the periodic table. Okay? Everything will be related to these steps. Now, when we do this, all right, when we're looking at these, the way we use them is as a ratio. Okay? So if we're looking at this one, there's two ways we can use this one. If they give us the number of moles to start off with, or if we've calculated the number of moles, that means moles would be on top. So for our conversion, where would moles need to go? On the bottom. So when we're using it and we start with moles, then the 1 mole would be on the bottom, and 6.02 times 10 to the 23rd would go on top. Okay? That's one way we would use it. If they give us, or we have calculated the molecules or atoms or whatever, all right, so if we have molecules on top, where would it need to go on the next step? On the bottom. So the other way we could use it is we flip it. All right? We put the 1 mole on top, and the 6.02 times 10 to the 23rd goes on the bottom. That is the two ways it can be used. All right? Likewise, this one, okay? If they give us moles of a gas, where's moles going to go on the next step? Bottom. Okay? And what it's equal to goes on top. 22.4 liters. Okay? Or if they give us liters and we're trying to get to moles, if I have liters on top, where would liters go on the next step? On the bottom. 22.4 liters and 1 mole goes on top. Are you with me? Okay, top and bottom have to be equal things. Top and bottom are equal things. It's a ratio. And I don't think we spend as much time in the younger grades doing ratios. Not your fault, not their fault. They've just changed their emphasis. It just causes a little struggle for me. Okay? All right? Now, the last one, all right, is dealing with grams. Okay? Anytime you got, it either gives you the value in grams or they ask for your answers in grams, stop before you go any further and add up the grams, and we'll do a couple problems like that and I'll show you what I mean. All right? But again, if they give us moles, where would moles go on the next step for this one? On the bottom. So 1 mole goes on the bottom, and then the gram formula mass goes on top. So GFM. Okay? And if they give us grams, and we have to convert it to moles, so if we start with grams, where's grams going to go on the next step? Bottom. So the GFM goes on the bottom, and 1 mole would go on top. All right? But the mole becomes my translator, right? It's like a long time ago, I went to this island in the Caribbean, right? And they had stuff for sale, but they were using their money. So I had to go to the bank, and the bank translated my American dollars into the money they used on the island of St. Lucia. So, because by doing that, I didn't get ripped off as easily when there's like, it's 5 St. Lucia dollars or whatever. I was like, how much is that? Oh, it's $5. No, it was like 50 cents or something like that. I don't know. It was crazy. So by having their money, I could do those transactions easier. Does that make sense? So the mole becomes our bank. That's where we go to change things around. Are you with me? So let's do a couple of examples. We're going to do a 1-step, and then we're going to do a 2-step. Actually, we'll do a couple 2-steps, okay? But we're always going to come back to this, all right? So let's say for the first problem that we have 0, is this a good spot? Yeah. 0.67 moles of SF6, sulfur hexafluoride, and we want to convert it to liters because SF6 is a gas. I'm going to go ahead and write that there. All right, we're going to convert it to how many liters? So that's a question mark liters. Okay? All right, looking at this, which one of our little conversions we're going to need? 1, 2, or 3? 2, because they're giving us moles and they're asking for liters. Does that make sense? So we always start with what they give us. So in our problem, 0.67 moles SF6 over, if you want to, put it over 1, or you can just leave it. All right? Now, if I have moles on top, where's it going to go on the next step? Bottom. From our conversion, how many moles? What number's with the mole? 1. Hey, look at all of them. It's always going to be 1 for these problems. A little later on, when we get into doing chemical equations, it will sometimes not be 1. But this time, 1 mole. All right? And we're going to liters, so how many liters goes on top? 22.4. Very good. All right? Now, after we get to this point, okay? That's too close to color. Let's use green. All right? We can cancel the unit mole. And we're left with the unit liter. So I know I've set up the problem right because my units work out right. So now I'm going to use 0.67 times 22.4. All right? And then I would divide by 1, but do we need to divide by 1? No. Well, I'll show it to you, but we'll go ahead and do that. So we got 15.008, just so you can see it. If I go divided by 1, guess what? It's still 15.008. It's math, all right? So we would say, now, we only had 2 significant digits, the 6, 7, so I only need 2 here. So I would say 15 liters SF6. Did you follow me? Anybody lost right now on this type of problem? Okay? So as long as it's a one-stepper, those seem to be pretty easy, I think. All right? Now, we're going to do a two-step problem. That doesn't mean we're going dancing. Anybody get that one? No? All right. Yeah. All right. But we are going to do a two-step problem, okay? So this next one, so I'm going to use a different color so we don't get them confused. We're going to say we have 77.6 grams of SO2 gas, and we want to get it 2 liters. So how many liters would that be? Okay. Looking up, that's not my conversion. Where's the one I just wrote out? That was the one from previous hours. All right, looking at my conversions, do I have any conversion that goes straight from grams to liters? The answer would be no. All right. Some of you are better with math, can kind of see how you can combine it. I don't want you doing that for now. It's just easier and you make less mistakes if you don't. All right. So we're going to go from grams to moles and then moles to liters. All right. Now, what did I tell you to do anytime we have grams or it asks for grams? The first thing we need to do is what? Do the math. We need to add it up. So we're going to stop before we set up anything else. We're going to add up SO2. How many S's are there? 1. How many O's? 2. Okay. Then we look on the periodic table. The mass of sulfur rounded to 1 decimal is 32.1. The mass of oxygen rounded to 1 decimal is 16.0. So 32.1 and 32.0. And we add them both together and we get 64.1. And remember, that is grams equal to 1 mole for SO2 only, right? Everything's got its own weight. All right, so that gets me grams to moles. And then what do I need to get to liters? What's my conversion? To get to liters after I get to moles? 22.4. So those are my 2 conversions I'm going to need. Again, we start with what they gave us. Oh, scrolling, getting it back up higher. All right, 77.6. I don't write my 7s very well. I mean, I'm not a very neat writer anyway, but 7s are one of my worst. All right, 77.6 grams SO2. Put it over 1. If I have grams on top, where's it going to go on the next step? Bottom. Grams SO2. How many grams? 64.1. Good job. It's what we added up. And what's that equal to? 1 mole. So we put 1 mole on top. SO2. All right. I'm going to go ahead and do this as one long problem, and then I'll go back and break it down if somebody wants me to break it down. Okay? All right. If I have moles on top now, because, right, my grams would cancel. If I have moles on top, where does it need to go on the next step? It goes on the bottom. And again, it's going to be 1 mole SO2. And what's 1 mole SO2 equal to in liters? 22.4. Good. It's always 22.4 for what we're doing. Okay? And again, now we can cancel moles. What unit am I left with? Liters. That's what I want. Right. So now I multiply everything on top and multiply everything on the bottom and divide. Well, the bottom is 64.1 and then everything else is 1. So it's just going to be 64.1. So that makes it easy. I can do it all on my calculator. Right? 77.6 times 1, I can skip it, times 22.4. Hey, McKinley. And I get 1738.2. And then we divide by 64.1. And we get a value of 27.1 liters SO2. Questions? You guys, does that make sense? Do you guys see how to do it? Take your time. Where people get in trouble is they go here and they go, they don't take their time to step the steps and they're like, I don't know how to get there. What can I convert this to? Well, I can convert it to moles. Oh, and then I can convert moles to liters. Does that make sense? Does anybody want to see me do it in two problems? No? Okay, we'll go on. I want to do one more multi-step problem. I'll do this next one in 2 problems, but I'll show you how you can do it in one, just to keep it grooving. Okay? All right. So we are going to go. Yeah, let's do this. All right, this one we're going to make a little bit more complex. Let's go. I've already done green. No, we're going to do green. All right, we're going to say we have 135.6 grams of FeCl3. Now, pay attention here. We want to convert it to number of molecules and number of atoms. Okay? So this part is a little bit extra, but once I show it to you, you're gonna be that's so simple. All right? It's probably the easiest part that we're gonna do. Okay, so we're starting with grams, so what's the first thing I need to do? Add them up, yeah, calculate its mass. All right? So, how many FEs? I got 1. How many CLs? 3. And then FE is 55.8. And CL is 35.5. Off of your periodic table. 1 times 55.8 is just going to be 55.8. 3 times 35.5 is going to be 106.5. All right? We're going to add it together. We get a 3, carry the 1, get 11, 12, carry the 1, get a 6, and put our decimal point back. So 162.3 grams FeCl3 equals 1 mole. All right? So that's one of our conversions we know we're going to need. Okay? So that, if we go back to that list of conversions I gave you, all right? So that's this one, but we want to get to molecules. Which other equation or which other conversion are we going to need? If we want to get to molecules. Yep. It's going to be the 6.02 times 10 to the 23rd. Sorry for those on the camera. I was nodding my head when somebody was responding, and you probably couldn't see that. All right. So we're going to need the 6.02 times 10 to the 23rd. All right. Again, always start with what they gave us. 135.6 grams FeCl3. Okay. And if I had grams on top, where's it going to go on the next step? Bottom. How many this time? There you go, 162.3 grams. Guys, I think you're getting a little more confident because I'm hearing more people not just saying out answers, but you're saying out the right answers. All right, so good job. And that's equal to 1 mole, FeCl3. And I told you guys I would do this in 2 steps, so we'll do that. And then I'll just real quick show you how you can do it in 1. All right? So 135.6 times 1 is just going to be 135.6 divided by 162.3, and that equals 0.8355, because we had 4 digits here, so we'll keep 4, and that will be moles FeCl3. Okay? So we will take that number, and that's going to start our second step, 8355 moles FeCl3. All right, but we want to get to particles. So if I have moles on top now, where's it go on the next step? Bottom. So 1 mole. And then how many molecules are in a mole? You guys said it. Yeah. 6.02 times 10 to the 23rd molecules. Maybe my YouTube videos will get me discovered. I'll become a famous singer. You guys don't think so? I can tell from your silence. All right, that's okay. 0.8355 times 6.02 to the 23rd, and I get 5.029, but that's going to round up, so 5.030. times 10 to the 23rd molecules FeCl3. All right? And before I show you how to do this in one problem, I want to go ahead and answer the second part, because the second part was atoms. Right now we're in molecules, right? Every molecule, and technically it's formula units because it's ionic, but we're going to just keep it this way. How many irons are in each molecule? How many Fe's? 1. How many Cl's? So how many atoms total in each molecule? 4. So if we needed to find our atoms, we just take our molecules times 4. Does that make sense? So we go times 4, and we get 2.012 times 10 to the 24th atoms. Now, if they wanted to know just the chlorine, because sometimes they do that, instead of taking it times 4, I'd take it times 3. Does that make sense? It's just weird what you might need. Now, you want me to show you how to do this in one problem? I will real quick. Okay, so we start off exactly the same, 135.6 grams FeCl3. If I have grams on top, where's it go on the next step? Bottom. And all we do is we just don't stop. FeCl3 and 1 mole. Now, if I have moles FeCl3 on top, where's it go on the next step? Bottom. All right, and the 6.02 times 10 to the 23rd molecules goes on top. All right? Then all you have to do is multiply straight across on the top, multiply straight across on the bottom, which is just going to stay 162. So you multiply the top, divide by the bottom, and you're done. You get the same exact answer. And I'll do it real quick. 135.6 times 6.02 to the 23rd divided by 162.3, and you still get 5.0296, so 5.030 times 10 to the 23rd molecules. All right? Okay, last thing, because this comes up on one of them. We did do this on our formula mass. When you have to add up a hydrate, CuSO4, and I'm not going to work the whole thing out, but I'm just going to show you how to set it up. All right, you can either do water as one thing if you know the mass of water. If you don't, I'm going to show you the most accurate way. How many Cu's do I have there? 1. How many S's? Just 1. How many O's in the front half? 4. And it's just easier. All right, now, there's 2 hydrogens in every water, right? But how many waters do I have? So what's 5 times 2? So there's 10 hydrogens. And then over here, there's 1 oxygen in every water. But I got 5 waters, so how many oxygens do I have there? Yeah. Instead of trying to finagle it and add them together there, just do them separate. Find their mass off the periodic table, multiply and add. All right? Anytime you have a hydrate, it'll just make it easier because that comes up. All right? Any questions before I shut off the video that might help the people on the video? Nope. Okay, let me shut her down.